Okay, welcome back. Answer your attendance, Afla, Ajmina, Amina,
Present, Miss.
Atulya,
Present, Miss.
Drishya, Jyotish, Karthik, Kavya,
Present, Miss.
Nachiket, Neeraj, Ranjit,
Yes.
Vaishnav, Anjali, Shruti.
Ma'am, I'm present on it.
Okay. Shruti is a who has joined now? Ajmina. Okay. Shruti? Yes, Nachiket, I'm not present. Okay, we will start our topic meanwhile taking the attendance. Okay, so the next topic, it's the last topic in your module 2 is the wireless LAN. I hope you all can see the slides. Now, wireless LAN. So far, you were discussing about wired LAN, that is Ethernet 802.3. Now, the next topic is the wireless LAN. Now, what is a wireless LAN? It is a flexible data communication system. When you are comparing wired LAN as well as wireless LAN is a flexible data communication system. Now, this acts as an alternative for wired LAN. It acts as an alternative for wired LAN. Now, the type of technology that is used is the RF technology. Now, you are transmitting and receiving the data over air. So, you are minimizing the need of wired connection. Okay. Now, what IEEE has defined this wireless LAN, how it has defined this, it has defined as IEEE 802.11. And actually, it is covering the physical and the data link layers. I have told IEEE 802.11 is a flexible data communication system. When you are comparing, it is an alternative for wired LAN and you make use of RF technology. Okay. Now, we are going to study dealing with the architecture of this IEEE 802.11. Now you can see here in this wireless LAN technology, this standard, it defines two types of services. The standard, it defines two types of services. One is called the basic service set. In short, you will be calling it as BSS, and the other one you will call it as ESS, that is extended service set. The first type of service is the basic service set, and the other type is called the extended service set. Now you can see a diagram where basic service set is shown. Now in this diagram, this basic service set is acting as the building block of wireless LAN. Basic service set is acting as the building block of wireless LAN. Now you have stationary as well as mobile wireless stations here. And you have also got a central base station. You can call it as an access point. If BSS is there without an access point, that type of network is called it as ad hoc network. BSS without an access point, you can call it as an ad hoc network or a standalone network. That means it cannot send data to other BSS. Okay, and the BSS with an access point, you can call it as an infrastructure network. So two type of networks I have told. One is the ad hoc network or the standalone network. The other one is the infrastructure network. So You have a basic service set that will be a mobile one or a stationary one, and you have an access point also. So if access point is there with the basic service set, you can call it as an infrastructure network, and if there is no access point, you can call it as an ad hoc network. Okay. Now the second type of service set is called as the extended service set. You can see in the diagram, it is made up of two or more BSS with APs. Okay, so here it consists of two or more basic service set with access point. Now this basic service set, they are connected through a distribution system. This basic service set, it is connected through a distribution system. You can see in the diagram. Now that is actually a wired LAN. Okay. Now this distribution system, it connects the access point in the BSS. The second type of service or the architecture is the extended service set. Extended service set means here you have two or more basic service set with access point. All these access points are connected through a distribution system. And that distribution system is nothing but it is a wired LAN connection. Okay. Now here you have got two types of stations. One is a mobile station and the other one is the stationary station. Mobile means it is the normal stations inside the BSS. You have stations inside the BSS and they are the mobile stations. And here in extended service set, the stationary stations are the access point stations, which are nothing but it is a part of the wired LAN. Okay, so I have told what is wireless LAN. Wireless LAN is a flexible data communication system. You can have two type of service sets here. One is called it as the basic service set. The other one is the extended service set. Basic service set, it is a basic building block and you can have stationary mobile stations or mobile stations, wireless stations inside this, and you can also have a central base station. You can call it as an access point. And if a BSS consists with an access point, you can call it as an infrastructure network, and without an access point, you can call it as an ad hoc network or a standalone network. Okay, and extended service set is nothing but if it is consist of two or more BSS with an AP. Now, how it is being connected is with the help of a distribution system. Okay, now the next one, what you are going to see is the MAC layers in IEEE 802.11 standard. MAC layers in IEEE 802.11 standard. You can see in the diagram, this 802.11, it defines two MAC sublayers. One is called as the point coordination function. In short, you will call it as PCF, and the other one is the distributed coordination function. So you can have two types of MAC sublayer in 802.11. One is the point coordination function. The other one is the distributed coordination function. Now, what is this? Actually, this PCF, it is an optional one and it is a complex access method. Okay, and that is usually implemented in the infrastructure network. That type of protocol is implemented in the infrastructure network. But the other type, distribution coordination function. Actually, that is one of the protocol at the MAC sublayer. Okay, and here this is similar to the access method what you have seen already. That is nothing but the CSMA-CA. When I taught CSMA-CA, I have told that access method is used in wireless LAN. Now, what is the expansion of CSMA-CA? AFLA. What is the expansion of CSMA-CA? AFLA is there? No. Jyotish is not there. Karthik is not there. Neeraj is there? No. Vaishnav? Vaishnav? Vaishnav is there? Vaishnav? Say, I'm marking absent for you. If you are not answering, Vaishnav is absent. Okay. Shruti, just tell the expansion of.
Hello.
Yeah.
Multiple access collision avoidance.
Yeah. Carrier
Hello?
sets. Yeah. Vaishnav.
Network പ്രശ്നമുള്ളേ ഹലോ
See, you have to either put it in the chat box or you have to respond. Otherwise, how I'll be knowing that you are available here? Okay, so Shruti has told carrier sense multiple access collision avoidance. Okay, so this DCF, it made use of the access method, that is CSMA-C. So what is the function of this
Hello.
CSMA-C?
ഹലോ കേൾക്കുന്നില്ലേ ഹലോ
You can talk to me after some time. I will give time for you to talk. Okay. So this DCF, as I have told, it make use of the access method, that is CSMA-CA. Now, what is the function of the CSMA-CA that you have already seen in the last class? So whenever a station wants to send a frame, what is the first process whenever a station wants to send a frame? It will be senses the medium, sensing the link or the line. Okay, now, and that is done with the help of some persistent strategies. You have gone with many types of persistent strategies. What are they? What are the different types of persistence method you have gone through? Yes? What are the different types of persistence method? Who will be answering? Ajmina?
Non-persistent,
Yeah, non-persistent and one persistent and P persistent, right? Persistent, okay. So by making use of any of the persistent strategy, it will be sensing the line. Okay, now once the station is found idle, what happens in this CSMA-CA is the station, it waits for a random amount of time, and that time is nothing but the distributed interframe space. When I told earlier CSMA-CA, I have just told IFS only. Okay, now in distributed coordination function, the time period is called it as distributed interframe space. Okay, interframe space is the time gap between the end of the frame and the beginning of the next frame. Okay, so what I told is, if a station wants to sense a medium, what it will do, sense a data, what it will be doing is first sensing the line. Okay, now once it find the line idle or the channel is idle, it waits for a random amount of time called the distributed interframe space. And it sends a control frame called RTS, that is a request to send. Understanding from the figure, so if a station wants to find the line is idle, it wait for DIFS and then it will send the control frame called the RTS frame. Okay, now after receiving the RTS frame, again it will wait for some period. That is called it as SIFS. SIFS means it is called it as short interframe space. Okay, again it will wait for a time period, and the destination or the receiver, it sends a control frame called CTS. CTS means clear to send. Okay, now once it reaches the central side, then the station is what is the indication of that CTS frame? It is indicating that okay, it is ready to receive the data. Now the source station wants to send the data, but when it will be sending the data, again it will be waiting for SIFS. A short waiting time is there again, then after that it will send the data. Okay, now at the destination, after receiving the data, In order to send the acknowledgement, it will wait again for SIFS. Okay, so after waiting an amount of time equal to the short interframe space, it will send the acknowledgement. The meaning is the frame has received. Okay, so that is the concept in CSMA-CA, that is the access method used in DCF protocol. So first, waiting time is DIFS, request to send frame, control frame is sent. Again, a waiting time is there, clear to send control frame is sent. Again, waiting time, the data is sent, and then SIFS waiting time, then the acknowledgement is sent. Now, this type of protocol is called carrier sends multiple access collision avoidance. Now, how it is avoiding the collision is by a feature called NAV that you can see at the right end of the figure. Okay, so NAV is called network allocation vector. So if two stations are involved in transmission, the other stations are in the NAV mode. They are not sensing the carrier. The meaning is collision avoidance is avoided by a feature called NAV. Okay, so the meaning is if a station wants to send a frame, I told it will first send the RTS frame. So in that RTS frame, you have the time limit that this much time is needed to occupy the channel. So RTS frame involves that time. Okay, so the stations that are affected by this transmission, that is the other stations, what they will do is they will create a timer called the network allocation vector. Okay, so the timer shows how much time each station has to wait after the time. I mean, if they want to check the channel for idleness, they want to wait for that much time, and that is specified in the RTS frame. So each station, if it is accessing the medium, it sends an RTS frame, and the other station starts their NAV. That is the working principle of the CSMA. That is how collision is avoided. Okay, understanding. So if two stations are involved in transmission, an RTS frame is sent. The RTS frame involves one more data. That is, it includes the duration of time that it needs to occupy the channel. Okay, so that will be released to all other stations, and all other stations which are not involved in the transmission, they will go to their NAV mode. NAV mode is nothing but it is a timer that states how much time they have to wait for checking the channel again. Okay, so the collision is avoided in case of wireless LAN. Okay, understood how the CSMA-CA concept is working, how collision is avoided in this case? Yes or no? The other stations who are not involved, they start their NAV mode, or the timer is started, and until and unless of that time, they won't be sensing the channel. Okay, so RTS frame includes the duration of the time that both the stations are involved in the transmission. Okay, so that is how collision is avoided in this type of access method. Right? Now, the next thing is the frame format of wireless LAN. IEEE 802.11, very important, the frame format of IEEE 802.1. Now, what does it consist of? Now, you can see in the diagram, it consists of 9 fields. The first field is the FCD, address 1, 2, 3, ASC field, address 4, frame body, and the FCS. Now, what is the meaning of all these things? So the first field is called, this is the McLear frame in IEEE 802.11. The first field is called it as the frame control field. It is of 2 bytes. Okay, and that defines the type of the frame and some control information. What type of frame you are making use of. I will tell what are the different types of frame in 802.11. So FC, it defines what is the type of the frame and what are the control informations present. Okay, and now you can see a subfield. That FC field is divided into many subfields. like protocol version, type, subtype, to, DS, from DS, etc., etc., etc. Okay, so thus subfields, it is coming under this FC. Frame control is having some subfields. Okay, now you just understand that much. Now, the second field is called it as the D field. It is of 2 bytes. Now, what does it indicate is, it indicates the duration of the transmission that is used to set the value of NAV. I told RTS frame, it consists of one more data that is called how much duration they are occupying the channel. So that is represented in this D field. Okay, so duration of the transmission is defined in the D field. Okay, now the other 4 fields, that is address 1, 2, 3, and 4, they are nothing but they are the address field. Each is of 6 byte. Now what it depends on? It depends upon the to address and the to destination address and the from destination address that is specified in the FC field. In the subfield you can see to DS and F from DS, etc. Okay, so these addresses, it depends upon these values, right? Now the other field is called it as the sequence control field. Sequence control field means it defines the sequence number of the frame to be used in the flow control. I have told when I taught flow control the importance of sequence numbers. Okay, so that sequence numbers in case of wireless LAN, that numbers for flow control mechanism, and that is placed in the SC field. Okay, now the next field is called it as the frame body, and that is from varying from 0 to 2312 bytes. This field actually it contains information based on the type and subtype defined in the FC field. The frame body, which is nothing but it will indicate the type of the frame used. I will tell you what are the types of the frame in 802.11. So whatever details are there in that type, that is specified in the frame body. Now the last field is called as the frame check sequence. Okay, so it is 4 bytes long, and what it consists of, the CRC detection sequence. Okay, so these are the 9 fields in 802.1. This also you have to study all the architectures or the standards. Frame format is very, very important. So frame format of IEEE 802.11, it starts with FC field. FC field means it's nothing but the type of the data as well as some control information. Now D is nothing but the duration of the time that is specified in the RTS frame. Now address 1, 2, and 1, 2, 3, and 4, it is defined, it defines the to address as well as the from address that is specified in the subfield of frame control. Now SC is nothing but the sequence control. It defines the sequence number that is used in the flow control method, and frame body is nothing but the information based on the type and subtype defined in the FC field. And the last field is called it as the FCS field. Okay, now what is the meaning of all these subfields is shown in the next slide. I have just told you have got different types of subfields like version, current version is 0, then the type of information. I have told the type of information I'll be discussing in a while. So the type of information, IEEE 802.11 has got 3 categories of frames. One is called it as the management frames. The other one is called the control frames, and the third one is called the data frames. So 3 types of informations are there. One is the management, the other one is the control frame, and the last one is the data frame. Now management frames, they are used for the initial communication between the stations and the access point. You have stations, you have access points. So if they want to communicate with each other, you are making use of this management frames. Okay. Now the second one is the control frames. So if you want to access the channel and if you want to acknowledge the data, you will be making use of this control information. Okay. And you have got different RTS control frame as well as CTS or the acknowledgement control frame. Okay, and this is also of many different fields like FC, D address 1, goes to FCS. Okay, so the type of the control frame for RTS, for CTS, as well as for acknowledgement. Actually, they are used for accessing the channel and for control, for acknowledging the frames. Now, the last one is the data frame, and they are used for carrying data and the control information. Okay, so these are then the other subfields you can just read it like when it is set to one more flag is required power management, then wired occupancy privacy, that is all for encryptions, then the other one is reserve field. So you just understand the main 9 fields, that is FC, D, address 1, address 2, 3, 4, SC, frame body and the frame check sequence. Okay, now 3 types of types of frames are there. One is the management frame, the other one is the control frame, and the third one is the data frame. Management, if you want to communicate between the stations and the access point, you will be making use of this management frames. Control, it is used for accessing the channel and for sending the acknowledgement. Data is nothing but the information. The whatever data you are sending, that is involved in that field. Okay, so this is about the frame format of IEEE 802. Understood? What is the basic architecture that is used in 802.11, and also very, very important, the frame format of IEEE 802.1. Understood? Yes or no? Atulya?
Yes, Miss.
Okay. Afla is there? Afla? Yes. Okay. So we have come to the end of the second module. Now what I will do is I will just refresh what we have learned all these 12 hours. 12 hours has been crossed with the second module. So what are the things that you have gone with the second module? So Drisha is not there. Then Neeraj is there? No. Vaishna? No. Vaishna is there. Okay. So, what all things we have learned in this module? Oh, I have not on the video, sorry. Okay, what are the things that we have learned in this module? Started with, very, very important, started with, which were the 2 layers that we have gone through this module? Amaya?
Physical layer, data link.
Okay, physical layer and the data link layer. Now in physical layer, what are the things that you have studied? Shruti?
Functions of physical layer.
Okay, then what is the main thing that you have studied in the physical layer? What is the function of physical layer?
Provide service to top layer.
Okay.
Frame.
Okay.
Frame is converted as signals.
Okay. Now how the signals
Take
are
care of physical
transmitted?
network.
How the signals are transmitted? Through what? Signals are transmitted to the medium. And you have learned the 2 different types of medium. One is the guided medium and the other one is the unguided medium. Unguided medium, you have to just refer textbook. I think you have already crossed with in different subjects, that skywave propagation, etc., etc., etc. So you can just read it and understand what are this unguided media. Okay. Now, guided media, what are the things that we have gone through it? Rangeet? Yeah, what are the things that we have studied in guided media? What are the different types of guided media? Yes?
Different types of media.
The types are പഠിച്ചത്? മറന്നുപോയോ?
Twisted pair
yes.
cable.
Twisted pair cable. Then
Coaxial cable.
Coaxial cable, then
fiber optical.
yeah, fiber optic cable. Okay, now you have seen the two categories of twisted pair cable. One is the UTP and the other one is STP, that is unshielded. You can mute your phone, twisted cable, and the other one is shielded twisted pair cable. And you have gone with the coaxial cable, and what are the different types of connectors, what are the categories, and how you are grading all those things. And the last one is the fiber optic cable. Now, what is the principle behind fiber optics and its composition and all, you have just seen. Okay, so that was the thing that you have studied in the physical layer. Now, the second one is started with which layer? Started with which layer? Vaishna, you have joined late. Why did you join late? Okay. Now tell, which is the next layer that you have gone through in your second module? Vaishna. Vaishna. Yeah, you can answer. Which layer you have studied after physical layer? Answer it. Vaishna? Okay, which layer you have gone through? The second layer is the data. Yeah, data link layer. Okay. Now, what is the first thing that you have studied in data link layer? What is the basic function or the responsibility of data link layer? It is framing. Yeah. Framing, it can have two types. One is fixed size framing as well as variable size framing. And you have seen what is the bit stuffing as well as byte stuffing. You have gone with very, very important. What is the difference between bit stuffing and byte stuffing? Okay, and that there you have studied that concept. And after that framing concept, you have gone with the flow control methods. What are the two different flow control methods, Atulya? Flow control methods.
Stop and wait, sliding window.
Yeah, very good. Stop and wait and sliding window. Stop and wait means one frame you can transmit at a time, and sliding window means more number of frames can be sent at a time. Okay. Now, after that, you have just gone with the error control methods. Error control and flow control. Now, what is the difference is in error control, you are doing the retransmission of data by a technique called ARQ. Few have marked it wrongly in the quiz, which I have asked previously in the module 2. ARQ, the expansion is automatic repeat request. I think few have made it wrong. Something else you have answered it. So it is the retransmission of data takes place in error control mechanism, and that is with the help of ARQ mechanism. And there you have studied three different protocols. What are they? Yeah, what are the three different protocols? Ajmina. What are the three different error control protocols? Yeah. What are they? They are? Nachket, you can answer.
Yes.
Yeah. What are the error control protocols?
Stop and waiting.
Stop and wait, ARQ, then
Sliding window ARQ.
sliding window ARQ. In that sliding window ARQ, you have gone with two categories. What are they?
Go back.
Go back and
Selective
ARQ and selective repeat. Go back in ARQ, whenever a frame is damaged, lost, or acknowledgement is lost, whatever is happening is, if a station, if the center, if it transmits many data after that, everything will be discarded in go back in. But in selective repeat, you have to study what is the difference between go back in and selective repeat. Selective repeat, only the only the packet which has got the error only is retransmitted, not all the frames. Okay, so it is selecting and then repeating the frame. So that is the meaning of selective repeat. Okay, so these are the two protocols that comes under the error control methods. Okay, now after that you have studied HDLC. Okay, HDLC protocol, it is a bit-oriented protocol. You have studied what is the frames and what are the mechanisms in that station types, etc. in case of this HDLC method. Okay, after that you have gone with the error detection methods. What are the two types of error detection methods you have gone through? Amaya? What are the two different error detection methods?
Cyclic redundancy check.
Okay, cyclic redundancy check, and the other one is
Checksum.
checksum. You have to go through one of the problem, what it is sent is as PPT. So you will be knowing how it is done. It is done with the help of binary division. Okay, so checksum as well as CRC, generator and checker, that is the error detection method you have gone through. Now after that, you have gone with the second function of the data link layer. First function is the data link control, and the second function is the MAC control. Okay, MAC access layer or the medium access control. There you have studied the multiple access methods. What are the different types of methods you have gone? Kavya can answer. What are the different medium access methods?
Random access.
Yeah, random access or multiple access, and beyond that, what are the other types methods? The first method is multiple access. After that, the advanced version
Career
CSMA, carrier sense multiple access. Then after that,
CSMA
CSMA CD and CSMA CA. And that CSMA CD is used in traditional Ethernets, and CSMA CA is used in wireless LANs. Okay. Now you have the flowcharts and all. You have to remember how it is avoiding the collision as well as detecting the collision. Now after that, you have gone with the local area network architecture, very, very important. That is 802.3. That is the traditional Ethernet architecture. There you have gone with some baseband implementations of that, like 10 base 5, 2, FL, etc. And also the frame structure of this 802.3. Now, today in this hour, we have learned with the wireless LAN, that is 802.11, its frame structure, as well as what are the architecture, what are the types of service set it accepts and all, like basic service set as well as the extended service set. Okay, so today only I'll be forwarding the PPTs as well as notes, the question bank, and whatever is related with module 2, I will be forwarding it through link base. You can just go through it. The assignment questions, read it carefully and answer. Take your own time and write it. Like what previous hour, what I have told. Don't copy it and write yourself individually. Refer the textbook, refer the notes, etc., and write the answers. And you have to write it very, very neatly. This time, if there is no margin and etc. and all, I will be reducing your marks also. So take an A4 sheet of paper, put the margin, and then start writing. And specifically, I have to tell to Shruti, you have to make use of black ink and you have to write the assignment, because once you are writing with light blue ink and all, it is not able to, I'm not able to read it perfectly. And also your handwriting, if it is a little bit, it is not proper means, again, it will be a big burden for me to read it. Okay, so make use of black ink if it is there. I don't know compulsory that, otherwise legible handwriting is required. Okay. Now, 2nd October, 3rd October, and 4th October, your unit test is scheduled. 6 questions I will be mailing it today, and that is from the assignment questions itself. So go through that, and any 2 questions will be asked for the exam. Okay. So tomorrow, 1st hour, come early, and I'll be starting with the 3rd module. Okay, I think the other staff has joined. Okay, thank you all. Today's absentees is Afla, Drishya, Jyotish, Karthik, Neeraj, Vaishna is present, right? Okay, and Anjali.